Hello everyone, this is Mix K. In this video, I'm going to go over the 3 examples we did in our notes on ionic bonding. I have a few other videos where I go over more examples and more information, but this is just those 3 main examples we went over in class for notes. If you need more help or more information, you can check out those videos. So the first thing is we're going to look at this first example, which has Mg, which is our metal, and O, which is our non-metal. Now, when we're naming ionic compounds, we always name the first element, the metal, just its normal name. So I'm going to start by just naming it magnesium. If you don't know the name of an element, you can look on the periodic table. The second part, I'm going to name oxygen, but when we are naming the anion, the nonmetal, we have to change the ending to IDE. Usually we get rid of the last 2 vowels and everything in between, but really it just takes a little practice to start to remember which ones end where. So oxygen becomes oxide. We change that ending to IDE. Now, the second part is we need to look up the charges, and our charges are found on our periodic table in the classroom and on these ones. So Mg has a charge of 2, and O has a charge of -2. So I'm going to write that down. Mg was +2. O was -2. Now, we need to find the balanced formula, and that means that we need to make sure that we have the simplest ratio of our positive and negative charges where it still adds up to 0. So the first step is I'm going to cross out the plus sign. I'm going to cross out the minus sign. And now I'm going to crisscross the numbers. I'm going to bring this 2 and put it down here. I'm going to take this 2 and move it down here. So now I have Mg2O2. Now this is a 2 to 2 ratio. So our next step is I need to simplify this. Now I know I can divide these both by 2 and get a 1 to 1 ratio. So I'm going to change these both to 1. The last step is chemists are lazy. They don't write the 1s. So I'm going to rewrite this without the 1s, and I get MgO. Okay. Now we're going to draw out the transfer of electrons. Now we're not going to do the full atom drawings. We're just going to do the Lewis dot diagrams. And for this, we need the valence electrons, not the charges. So if I look at my periodic table, find Mg again, I come up to the top. Mg has 2 valence electrons, and O has 6 valence electrons. So I'm going to draw them in our special order. Up, down, left, right, up, down. Now our metal has less electrons, and it's going to give them away. Now, underneath these 2, it has a full octet. It has 8, so it has extra electrons here. Oxygen is really close to having 8, so it's going to want to take those electrons. So we're going to draw these electrons transferring over from magnesium to oxygen. The way we know we're done, magnesium has lost all of its extra valence electrons. Oxygen now has 8. And if we look at the amount of each atom we have, it matches our formula. I had 1 Mg, 1 Mg, 1 O, 1 O. Let's look at another example. I'm going to just scooch this up like this. Okay. So if I look on my periodic table, I can see that K has a positive 1 charge and I has a negative 1 charge. I'm going to write that down. Now, if I didn't know the names of them, I could look it up, but I know K is potassium and I is iodine. Now, I have to change the ending to IDE. So iodine becomes iodide. I change that ending. Now I'm going to do my crisscross. I take my charges. I get rid of the plus and minus sign. I don't need them. And then I'm going to crisscross the numbers. So I move them down. I switch them and I move them down to the bottom. So now I have K1, I1. Now, if there's a 1 in the ratio, it's already as simple as it can be. So I have a 1-to-1 ratio here. Chemists are lazy. They don't write the ones. So I'm going to rewrite it as Ki. Now to draw my electrons transfer, I'm going to look here. I have 1 K, so I'm going to draw 1 K. I have 1 I, so I'm going to draw 1 I. Whoop. I check my periodic table. K has 1 valence electron. I has 7. So I'm going to draw those in. K has 1 valence electron. I has 7. Down, left, right, up, down. Now I can go to the right here. It doesn't really make a difference as long as I'm going cross to cross. Okay, my one that has less is going to give it away to the one that has more. K gave them all away. I has 8. Matches my formula, 1K, 1I. Okay, one last example. Mg is plus 2. N is minus 3. So I name this magnesium. Now N is nitrogen, but I have to change the ending to IDE, so I end up with nitride. Nitride. Now for crisscross, I have Mg plus 2, N minus 3. I'm going to get rid of the plus sign and the minus sign. I'm going to crisscross them. So now I have Mg3 and 2. Now, I cannot reduce 3 to 2 to anything simpler. If I try to divide them both by the same number, I'm going to end up with a fraction. So this is actually our final ratio for this one, 3 to 2. That means we have to draw a bunch of atoms down here. I need 3 magnesiums. And I need 2 nitrogens. If I look at my valence electrons, I know that magnesium has 2 valence electrons. And I know nitrogen has 5. So I'm going to draw those in on both of them. Each magnesium. I lost my pencil. Hold on. There we go. Each magnesium has 2. Each nitrogen has 5. The one that has less is going to give it to the one that has more. So magnesium is going to give 1 here and 1 here. But we have a problem. Nitrogen still needs 1 more. So it's going to take it from another magnesium atom. Now this magnesium still has 1 to give away. So it's going to give it to this nitrogen. Now this nitrogen still needs 2 more. So it's going to take it from this magnesium here. Now each magnesium has given all of its extra valence electrons away. Each nitrogen now has 8. We can see that it matches our formula, 3, 3, 2, 2. Okay, so I hope that this video is a little bit helpful and helps you get caught up on some of the notes. These are the 3 examples we went over as notes in class. The rest of the examples in your packet are work for you to do. Yeah, that's it. Have a great day.